All right, good morning. Let's see. Yeah, so there's a question in the chat about ODP 409. We're going to talk about 409 in a second, but general comment. Remember, when you use scanf to check the validity of, say, trying to read a single integer, the only possible thing you can do to see if you read exactly one integer is see if scanf returned 1. That's the only thing to do. Don't try to see if it's different from 1. Don't try to see if it's 0 or 2 or if it's this or that or something else. Just see if it's equal to 1. Right? If scanf returns 1, you scanned exactly one integer. If you did not scan exactly one integer, scanf is different from 1. But it's not necessarily 2 or 0 or -1 or 3 or something else. It's either equal to 1 or different from 1. That's the only thing you ever want to check if you're scanning one integer. If you're scanning two integers, see if scanf is equal to 2 or different from 2. All right? It's not exactly the same thing as other things that sound similar. And that's one of the things that ODP 409 will test for. All right, so let me kill this light. All right. Let's talk about ODP 409, and then let's talk about the midterm. Any questions on 408 first? Or anything else? All right, so let's do ODP 409. All right, 409, similar to 408, but with the difference that it is doing complete error checking. All right, so you're still going to take a command line argument, treat it as a double precision floating point number, print its square root. Right? The difference is you have to check for all possible errors. So what can go wrong? You may call this program, you may run this program without exactly one command line argument. You may have no arguments, you may have 2 arguments, you may have 20 arguments. Any issue with the number of arguments, print out ERR followed by a new line and exit. That's it. All right. If you have exactly one argument, but it's not a valid double precision number, print out INV followed by a new line and exit. Okay. So what do we mean by not a valid double precision number? It's a collection of characters. It's what looks like a good number followed by extra stuff, anything like that. Okay, this is using the scanf with 2 arguments where you do the %LF followed immediately by a %S, and you throw the extra stuff into just a junk array, right? And if scanf parses just a double and nothing else, it'll return 1. If there's extra stuff at the end, it'll return 2. If there's not even a double in the beginning, it'll return 0. If there's an empty argument, it'll return -1. Right? So did it match just a double and nothing else? See if it returned 1. All right. If it does, you're good to go. If not, print INV. Next, you have to make sure the number is not negative. If it's 0 or if it's bigger than 0, that's fine. You can take the square root. But if it's less than 0, you can't take the square root, print out neg, followed by a new line, and exit. Otherwise, you get through all of those tests, print the square root. All right, and this is a flow that we'll see again and again in the startup to programs typically, which is running through a series of arguments, and a flow chart, you know, is an old school thing. It goes way back before computers, but it kind of makes sense. So, you know, So is argc equal to 2? Right? If argc is, let's see, hold on a second. Yeah, if argc is 2, then you're good to continue. If not, you've got an error condition. If argc is 2, try to parse argv bracket 1. All right. Did the scanf return exactly 1? If no, that's an error. If it did, now you know that you have a double precision floating point number. Let's see if we can take its square root. So is the number bigger than or equal to 0? If no, we've got an error. If yes, print the square root of the number and exit. All right. It may seem silly to write something like this out, but it can help if you're getting seg faults, you're getting weird things like NaN or stuff like that, right? This is the logical flow. And really important, we're checking argc before we check argv bracket 1, right? By the time we get here, we've got to know that argc is at least 2. Well, we're ensuring that it's actually equal to 2, so we know it's at least 2, right? But this has to work, this has to work, this has to work before you print, right? And each of these correspond to those 3 different messages that you might print out: error, invalid, and negative. All right, so code that up. That's ODP 409. You still need the -LM switch. You still need to include math.h. And just as kind of a reminder, right, the whole way that the assess program works is you say assess, name of the executable file, name of the source file. All right, so if your source program was called blah.c and you said gcc-o haha blah.c-lm for some reason, you would say assess haha is the executable program, blah.c is the source code, right? But don't do that, right? That's just going to make things confusing. So 409, call your program ODP 409.c gcc-o. Sorry? Oh. Thank you. GCC-O ODP 409 ODP 409.c. Right? So you know exactly what program you're working on. You can keep this around. It's not going to interfere with some other main.c that you write. You have the executable. It's not going to get stepped on by some other ODP. And your assess command is now completely unambiguous. Executable name, source program name. And I've seen lots of people get tripped up in the past by, calling all of their assignments ODP and calling all of their executables a.out. And it's just asking for confusion. And if you assess, something that wasn't the compiled version of this, you're not going to get any feedback that's going to help you figure that out. And you can end up changing your code for 6 hours trying to find the bug. And the problem is you're just assessing the wrong executable. And that's really frustrating. All right, so that's 409. Any questions on that? All right. let's talk about the midterm and such. So, so midterm should be unlocked so you can look at it. Feedback is in the comments in Canvas. And there was a real mixed range of how people did on the exam. So first thing, I don't want anybody to feel like they have to give up at this point, okay? There were some low scores on the midterm. The average was around 60, I think. So if you got a 60 or a 50, I mean, you're in, you know, a group with a lot of other people. I don't want you to think, you know, well, I added it up and the best I can do is a C minus and I'm not going to be able to pass, okay? There's usually some curving that happens in the course. My biggest concern at this point is by the end of the course, I want you to be good at working in a Linux environment. I want you to know how to do scripting. I want you to be really solid in C programming, okay? If you can demonstrate by the end of the course that that's where you are, then you're almost certainly going to move on to CSE222. Okay. So how do you demonstrate that? Well, if you underperformed on the midterm, but you do really well on the final, right? The difference between those will factor into how things are curved, usually. In other words, if numerically adding up your midterm and your final brings your score way down, right, I may underweight the midterm. I'll certainly, the final exam is cumulative, so I'll certainly, if you do well on all the material on the final, right, that will certainly help to offset the impact of the midterm. So I want you to concentrate on moving forward, right, trying to make sure you're solid on all of these things, the things that didn't click for you on the midterm, right? Let's work on those and make sure that you're on top of those and those won't be an issue going forward, including for the final. There are no answers posted on Canvas for the midterm, so it's not that the answers are hidden. I didn't put answers in there, okay? We're going to talk about the solutions to the problems today, but I didn't put them in there. Oh, you can't see what you wrote. Okay. I don't know what to do about that, because I unlocked everything. Let me see. Alright, we'll do a little Canvas sidebar here. I think I know what to do about that. Let's see. Okay, here we go. Aha. All right, try looking at your midterm again. I may have been able to let you see your answers. You'll have to at least refresh. All right, cool, awesome. I learned something. Yeah, you get 0 points for your name. All right, cool. So, so general comments on the midterm. Continuing. You want to be able to ideally, you know, sit down and write code on paper, okay, or on a board, without having to use a compiler. This is one reason I say don't be using an IDE. You absolutely don't want anything that's completing code for you, okay? Personal preference, I would not want anything that's doing indenting for me, because there's a function to indenting. It's not just going back and looking at your code. It can also be helping you when you're writing your code to know in your head where you are in the level of nesting, right? And by using your muscles to indent your code, you've got another reinforcement to go along with what's in your head about, I'm inside the else piece of an if statement, which is inside a for loop, which is inside a function, right? And that awareness will take away the mystery of, how many closing brackets do I need and where should I indent these? And almost always I see students at this level of the program treating brackets like a mystery, like a puzzle to solve. I got an error about this bracket over here. Maybe I should get rid of it. Maybe I should add another one. And you can see this in code because you'll see, beautifully indented code, and then you'll see 5 brackets all left justified, right? Because someone kept adding brackets until the error went away. That's not the way to be thinking about nesting, okay? And so writing code on paper helps, sort of force you into this mindset of what's going on in my code. Why am I putting brackets here, right? Because I'm done with that level of nesting. Now I'm going back one level. Where is that level? Is that the end of my if, or is this the else piece of my if? All right, so writing code on paper can help. I tell you, when you're working on, a large programming assignment, write it in pieces. Write one piece, test it. Write another piece, test it. But for things like ODPs, or short things that you're trying to write for yourself, I would say try to write the code beginning to end in such a way that it compiles the first try. Now, there's always going to be little syntax errors and things like that. You'll miss a semicolon or have an extra parentheses or something. But try to write it as correctly as you can instead of writing it and relying on the compiler to say, you forgot a semicolon here, you didn't declare what type of argument this was, things like that. That will also help you kind of be in a mindset of trying to write clean code when it comes time to do that on a test. So things like that, but overall, the best possible advice I can give you is just keep writing code, right? Anytime that you can spend time, write code, okay? There's websites you can go to that have, hundreds or thousands of practice problems, little drill questions that you can code up. I've got friends who, graduated years ago. They're off making 6 figures in industry, and they still do coding practice from the web. And they go to a site and they pull down a problem and it says, do such and such, and they'll try to code it up. And they'll challenge themselves to do it in a certain amount of time. The more you write code, the better you're going to be at writing code. So there's an old adage about 10,000 hours. That's what it takes to get really good at something. So the Beatles, played guitar for 10,000 hours to become the Beatles. So 10,000 hours. All right, so there's another rule of thumb. This does not work for most of us because life is really complex, especially now, right? But in an ideal world, the rule of thumb is for every hour you spend in a class, you should spend 3 to 5 hours outside of class. Okay? And so, yes, Beatles were in Liverpool. So engineering, CSE224, 50 minutes a day, 3 to 5x, right? That's basically 2.5 to 4 hours a day, ideally, that you would be spending on this course outside of class. Okay? Now that's a lot. And if you tried to do that for all your classes, you would never eat, you would never sleep, you would never do anything else, right? And most of us just aren't in a situation where that's practical. But if you spent, 3 hours a day just programming, right? Just writing code, where would that leave you? So if you did that 7 days a week, that would be 21 hours a week. 50 weeks in a year, that's 1,000 hours a year. That would take you 10 years to hit 10,000 hours. Okay, that's for 3 hours a day, 7 days a week. 10,000 hours is a lot. And it's not, like a scientific number, but it's kind of a benchmark. It's an approximation. The more time you can spend writing code, the better. And if you have, a chunk of time that's actually free that you can really just kind of put your head down and plow into it, it's nice to have some things in mind to work on. Problems that you're interested in, something that you're curious about, or stuff that you download from a website, or of course, problems in class. But ideally something that's fun, something that's interesting to you, will tend to make it easier to put that time in. So that's all right. And some of you just posted a website. I don't know this one, but check it out. Oh yeah, Project Euler. Okay, yeah, totally. There's also W3 resource, which has lots of like practice problems. And if you're curious about these, let me know. All right, so let's talk about the actual midterms. So I'll say this again when we get to the final, but on the midterm, logistically, it was a bit chaotic, right? So final exam will be at a specific time, and it will have a specific time limit. This was a 50-minute exam, but I told you that I would keep it open for 55 minutes. But the goal was at 50 minutes, you turn it in. And then if, it doesn't want to submit or you have trouble pasting something, you got a few minutes of wiggle room. But, about 10% of the class waited until a few seconds before 55, and they missed the timer. I don't know if they waited, but for whatever reason, they missed the 55-minute cutoff, and that was it. The exam was submitted with missing answers. So you want to pace your time accordingly. Okay. Bash code has to be written as discussed in class. For loops are not allowed. Okay, this is right in the description. We talked about this week 1. I'm going to continue with this for the rest of this course. After this course, you're free to write bash however you like. But if statements, while loops, conditionals, arithmetic need to be in the way we've described. All right. So let's jump into the questions. Question 1 is the honor statement. You get 0 points for this, but and I'm not sure what to do about enforcing this. There's lockdown browser options. I think Izad required students to leave their cameras on during his exam yesterday. I don't want to go that route, okay? But I do want to make sure that everybody is using the same resources. So my goal was you can use your notes, right, which includes old code. You can use an editor, right? And if you need to get on the Linux server to use the editor, I said okay, but I don't want people trying Unix commands on there, compiling code, things like that. I don't want people using editors that check your syntax for you, or compile your code while you type, or things like that. All right, so and I called these things question 0, question 1, question 2, but those titles that I gave don't show up anywhere, and it just starts numbering from question 1. So that's why the questions at the end had weird numbers on them. It's just more stuff to deal with. All right, question 1, 2. Write a C function named integer do stuff. Okay, this is a function prototype. It takes no arguments. It returns an integer. Should prompt the user with a greater than sign. Accept an integer from the user. Return twice that integer's value. Okay. If it does not receive exactly a valid integer, it should prompt the user and accept an input. All right. And it just keeps repeating as many times as necessary. All right, if you look at this specification, there's only one thing this function should ever print. That's a greater than sign followed by a space. And then it waits for you to type something in. Now, I didn't take off if you printed extra stuff. Okay, but if this was a spec handed to you by a customer and you were printing out things in the middle, they might not accept it. And it's not supposed to print the final answer at the end. It's supposed to return it as the function value. So, so how do we do this? So there's different ways to spin this up, but the basic idea is print a prompt, get a line of input, parse it. If it's a valid integer, return twice its value. So so something like this. All right, so start your function, however. Print out your prompt. There's no new line necessary there because the fgets will flush. Read a line of input. Try to parse it as an integer, and because we want to notice other stuff at the end, put in a %s to pick up extra stuff. Save this if you like. If it returns exactly 1, it got a good parse, return 2 times the number. And then, you know, one easy way to make this loop is just throw it all inside a while loop that runs forever. So while 1, print out a prompt, get a line of input, parse it, check the parse status. If it parsed successfully, return 2 times the number. Otherwise, you'll go back up to the top of the loop and repeat that. All right. There's other ways to do this. You could print your prompt, you could do your fgets, and then you could say while scanf is not equal to 1, and then inside your loop you could print an fgets and go back up, and then when you exit your loop you could do your return. You could say while you could initialize a done variable to 0, and you could say while not done, do all of this, and if return is equal to 1, you could set your done flag to 1, and then when you come out of your while loop, you can do your return, and so on. Lots of different ways. All right. Make sure you declare your variables, though, and sometimes it's easier to write your code first, keep track of what variables you're using, and then declare them when you're done. So we need space to read in the user's input. We need space for this extra thing we're going to pick up. We need an integer to write our number into num, and we need an integer for our return value. All right, so something like that. All right, so so issues that I saw in here. So one big issue, not checking for exactly an integer, right? Writing code so that if you did 23.5, it would treat it as 23. All right, and we had ODPs on this. We talked about it for at least a day in class, right? If you want to make sure there's nothing else after that integer, use that %s to pick up anything extra. So that was one issue. A bigger issue was not checking the return value from here at all, just doing your scan and then running with that number. And if your input doesn't have a valid integer, your number is not going to get assigned a value by your scan function. And you're going to be printing twice whatever the number happened to be before you started trying to parse it. So so that's a problem. Not doing fgets, right, and just starting to scan a string without waiting to, you know, get that string from the user. So syntax, you know, if you're missing a semicolon, I'm not going to take off points. If your parentheses aren't quite balanced correctly, or your angle brackets, you know, you're missing a closing angle bracket, but it's still clear what your nesting is, that's okay. If you did, you know, 1 equal instead of 2 equals, I took off 1 point once, just because that's the hardest mistake to find, and I want to make sure people are aware of that. But fgets, if you're not putting in standard in here for the third argument, if you've got, something like fgets buffer 120 or 120 comma buffer or something like that, that's a fundamental problem, right? Fgets is character array, length of array, and then where you're reading from, which is always standard in for us. So saw some minor fgets problems. Declaring your buffer to be a char star will not work for this, right? Char star buffer does not allocate space for the character array itself. Okay? When you want to allocate space, you say char buffer bracket, how much space you want. If you say char star buffer, you're saying buffer points to a character, but you're not saying where it should point, and you're not saying what should be at that location it's pointing to. And if you try to scan a char star that you haven't set up like that, you're probably going to get a seg fault. Okay. I took off a few points if I found redundant code, or code that really doesn't make sense. For example, if somewhere in your code you have a return statement, and then you have a statement right after that, like if something, right? This makes no sense. If this is an unconditional return, this is never going to get executed, right? And even if, technically your program would work correctly the way it was written, this kind of sets off an alarm for me. Like, do we understand that return takes you out of the function, and that's it? You're never going to get to this next statement. Some languages like Java will refuse to compile if you have something like this. It'll say unreachable statement. So I made note of those. If you didn't prompt the user for input, I took off a couple of points. Because usually when you're waiting for input, we ask that you do something to let the user know. Okay, so that was why it asked you to print out a prompt. Extra output, I didn't take off any points this time. A few people squared the number instead of multiplying it by 2. So I took off a point for that. A couple of people used a recursive solution here. Don't use recursion unless it's really necessary. So what some people did, if you don't know recursion, don't worry about it. What some people did was they checked the return value. If it wasn't 1, then they called do stuff. Okay? Yeah, that'll work technically, but it's limited, right? If I put this in a loop where I just wanted to, put in a million bad numbers, that would blow up. Okay? Whereas a loop, right, you can run this forever. You can continually put in bad numbers and it'll just keep looping, and it's not doing something that needs to be undone later on. Alright, what else? Scanf argument error. There should not be an argument to the function, right? When you're given a prototype, it means, this is what the function should be declared as. Alright, so I think that was it for question 2. Let's take a look at question 3. And if you have questions along the way, definitely just shout out. Alright, question 3. This was a program that processed command line arguments. So remember, there's 2 ways we feed programs information. One is runtime inputs, that's typically using fgets. The other is command line arguments. That's when you specify information on the same line as when you're running the program. So here you're writing a C program, not just a function, that you're going to run with 2 command line arguments. So you're going to say something like, main 3 5. And when you do that, the 2 arguments should be integers. First one should be less than the second, and you should print the sum of all integers between them. So this should say 3 plus 4 plus 5 equals 12, and it should print out the value 12. Alright, and if any of the following errors occur, you should print a message and just exit immediately. If you don't have exactly 2 arguments, if either argument is not an integer or exactly an integer, right? So question one's definition, or if the first argument is not smaller than the second argument. Okay. Any of those occur, print an error message and get out of there. Otherwise, calculate the sum of all integers between those two arguments, including the arguments themselves. Print that out and exit. All right, so you can make your main function int or void, it doesn't matter. But you got to pass arguments to it, which means we need an integer and a char star. And you can do char star argv, you can do char star argv bracket bracket, whichever one makes sense to you. All right. What's the flowchart look like here, right? What do we need to be able to do? First thing is we've got to have exactly 3 arguments, including the program name, right? So 2 command line arguments. So argc has to be equal to 3. All right. If it's not, we're not even going to parse any integers. We're not going to compare any values. We need to make sure that we have the right number of arguments. So if argc is not equal to 3, I don't know, I'll just call an error function. If I was typing this instead of handwriting it, I would probably just say, you know, printf error \n and then return 0. I'm just going to do an error function here because it's quicker to write. Okay, if argc is 3, we need to parse both arguments. Our arguments are in argv bracket 1 and argv bracket 2. All right, so if 1 is not equal to scanf argv bracket 1 %d %s address num1 extra, we'll just error out. All right, there's a lot happening here, right? We're taking that first command line argument, we're trying to parse it as an integer and see if there's anything else after that. We're doing that with scanf. We're taking the return value, comparing it to 1. If this is different from 1, something went wrong, so we'll go ahead and print our error message. All right, and then I'll repeat the same thing, except I'll parse argv bracket 2 and I'll save the result in num2. All right, so let's list some variables while we're in here. So we need space for extra. And again, you know, minor security issue here, but we can check the length of argv bracket 1 and we can truncate it to, you know, 119 characters if we want, and then we won't have a buffer overrun here. So we need that. We need a couple of integers to save our parsed arguments in. And I'm not going to save the return value from scanf. I'm just going to compare it right here in place, so I don't need my return variables like I had before. All right, so if we get through this, we've got exactly 3 arguments. If we get through these 2 statements, they are integers, and they are exactly integers, and they're totally valid. All right, last condition, arg1 has to be less than arg2. So if num1 is greater than or equal to num2, let's print an error message and exit. Now I could put else's on here if I wanted, but I'm going to do an exit inside my error function. But you know, if I wanted to exit from main, I could say if this, then print an error, else if this, then print an error, else if this, else if this, else, go ahead and do the actual sum calculation. All right, so calculate sum. So set a running sum equal to 0. start an index at num1. We're going to go up until I is as long as I is less than or equal to num2. And we're just going to do sum. I'll write it out explicitly. Sum equals sum plus I. And then print out your sum, and we're done. I think we're printing at the end. Yep. All right. So this is your running sum calculation, right? And start at num1. I'm going to add that to my sum. I'm going to go to the next integer, add that to my sum. Go to the next, add that to my sum. I'm going to continue as long as my number is less than or equal to the ending point, num2, keep adding to my sum, and then when it's bigger than num2, I'm done, and I can go ahead and print that sum. All right, so and then error. Print out some message. And you can do an exit. And in the beginning, include standard io.h. And then if you're going to use exit, go ahead and include standard lib.h. Lots of different ways to wrap this, right? Cleanest way probably is, you know, up here, just go ahead and print your message and exit with a return. You could technically do this in probably one big gargantuan if statement, because C will evaluate from left to right, and if you do a bunch of ors, as soon as one thing is true, it won't evaluate the other pieces of the expression. So you could start off with if argc is not equal to 3, or 1 is not equal to that, or 1 is not equal to that, or this is bigger than or equal to that, then print an error message and return. And if you don't return, then you can just go ahead and calculate your sum. All right, so issues I saw in there. So not checking argc at all is a problem, right? Because if I don't have enough arguments and I start trying to scan argv bracket 1 or 2, you're looking at a seg fault. So you definitely got to check argc. argc should be equal to 3. If you tried 2 or instead of 3, I only took off a point, because that's just something you figure out, and that's usually a trial and error thing. But you've got to check argc, right, before you do anything with argv. You got to detect the extra input after the integers, right? You've got to check the return value from scanf to see if you had an integer in the beginning. A few people decided to make a for loop where they took consecutive integers and saved them in an array, and then wrote another for loop to go through and add up the elements of that array. And while you might be able to make that work, it's extra work, it's limited in how many numbers this will run with, and it's not really necessary, right? If you have a way to go through all of your integers, just add them as you're going through, right? Instead of saving them somewhere. Let's see, so if you didn't prototype your main program, then most of this didn't work, right? You can't be checking argc, you can't be scanning your arguments correctly, and so on and so forth. You cannot compare argv as if it's an integer. A lot of people said if argv bracket 2 is bigger than or equal to argv bracket 1, argv is not an integer. That's why we're doing scanf, right? We're doing it to convert argv into num1 or num2, and then these are our integer arguments. And those are the things you want to work with for the rest of the program. Right, you needed to print an error message of some kind. I didn't care what it was, but you needed to print something out if you weren't going to print the sum. There's no reason and there's no place for an fgets anywhere in here. Okay, you're not reading input from the user. You're running a command and giving it 2 numbers on the command line and printing out the sum. of the numbers in between. What else? Make sure you initialize any variables that you need to have a particular value. So a lot of people didn't initialize their running sum. Some machines, some compilers that works, some it doesn't. It's not guaranteed that uninitialized variables will be equal to 0. Alright, so make sure you always are explicit about that. Make sure you declare all of your variables. Make sure your main program is called main. I'm going through my list of things. Make sure you printed the final sum. And a lot of people did not compute the sum of the numbers between argv1 and argv2. They either returned argv2 or they returned, the first number plus the second number. That doesn't give you the sum, right? You're supposed to print the sum of all integers between those arguments, including the arguments themselves, right? That tells you that you got to have a loop of some kind and you got to have a running sum. Okay, and if you haven't coded something like this before, it looks kind of weird, right? I mean, you've done this in 121, but if it's been a while, sum equals sum plus I is kind of a strange thing. But this is a standard construct you'll do again and again and again, right? Initialize something, and then as you go through, keep adjusting that inside your loop. All right. We're down to 3 minutes left. Let's see what we can do on question 4. You're not allowed to use for loops in Bash, right? So that was a comment in the beginning about how you have to write Bash scripts, and that's the comment from week 1 that you have to use whiles, ifs, and conditionals the way we've described, and you're not allowed to use for loops. All right. Bash script that asks the user to enter a number, prints all numbers from 0 to that number. Let me show you an example of this, but we'll talk more about details of it tomorrow. Put your shebang in the top. Print out a prompt. My quiz is running out of time. Read a number, and then we want to print out all numbers from 0 up through that number. If the number is 0, just print 0. If the number is negative, print nothing. So we could do something like this. I equals 0, while I is less than or equal to num. Do echo I equals I plus 1, done. Those are square brackets. All right, so prompt the user for a number, read the number, set a loop variable to 0. While that number is less than or equal to the number that was entered, echo it, increment it. All right, so if your number is negative, this while loop will never execute and you won't print out anything. If your number was 0, 0 is less than or equal to 0, this will run once and print out a 0. If your number is 5, this loop will run while I equals 0, 1, 2, 3, 4, and 5, and in each case it will print out that value of I. So that would give you the intended behavior. But I need to talk about a lot of issues that I saw on that one. So we'll pick up from here tomorrow. We'll talk about that, and then we'll talk about question 5, which was the other Bash program that repeatedly asks you for numbers. And then questions 6 through 9 didn't see a whole lot of issues with that. Most people were spot on with that. And most of the Bash stuff tended to look better than the C stuff. The main point losses seem to be in the C code. But we'll talk about specifics for question 4, and then we'll look at code for question 5 tomorrow. All right, so I will see you next time.